This is the Algebra 1 Unit 5 practice test. So we'll just work these problems and see how it goes. So here we go. Here's problem number 1. So problem number 1. So they give us this inequality, and they ask us to write that in interval notation. So this means that x is between -7 and -2. X could be equal to -7, but x cannot be equal to -2. So in interval notation, our smallest number x could be would be -7. Biggest number x could be would be -2. It can be equal to -7, so we use a square bracket. It can't be equal to -2, so we use a round bracket. Square bracket on -7, round bracket on -2. So here, and I'm going to use the interval notation tools that they have on here. I've got a square and a round, so we've got -7 to -2. Question 2. So here they're asking us to write x is greater than -1 in interval notation. So if I looked at a number line, right, here's 0, here's -1, x could be any of the values bigger than -1, right? So we have an arrow that looks like that. Okay, so the smallest value that x could be would be -1. And the biggest value, well, there is no biggest value, so we'd say that that's infinity. And so this is an open circle here, right? It can't be equal to -1. And so we use a round bracket, and then for the infinities, we always use a round bracket. So -1 to infinity. Use interval notation here. So we've got 2 rounds. We've got -1 and infinity. Okay, so on that right-hand side, we always use the positive infinity. We use the negative infinity only on the left-hand side. So let's go ahead and submit that. That looks good. Question number 3. So they give us an interval here. So number 3, they give us the interval from -5 to positive infinity. Okay, so on the number line, right, -5, 4, 3, 2, 1, 0, 1, 2, 3, and so forth. So -5, it's got a square bracket, so it could be equal to -5. So we want a positive, or we want a solid circle there. And then the right-hand side, there's no end to that, so that's just going to keep going on forever. So -5 to positive infinity. Okay. So it won't be that one because of that square bracket. Number 4. So they give us this graph here from -2 to -1, and we've got solid circles on both of those. So the smallest x could be would be -2, the biggest x could be would be -1, and we would have square brackets on both of those. Okay, because of the closed circle, they could be equal to -2, could be equal to -1. Intervals here, square brackets, -2 to -1. Question 5. So here they give us this inequality, y plus 1 is less than -2, and they ask us to solve that. So they ask us to solve that, so we'll just subtract 1 from both sides, and so we get y is less than -3. So on that number line again, here's -3. I'm going to have an open circle that's going to go this way. Okay. So the smallest x could be would be -infinity on the left-hand side, and the biggest x could be would be -3. It can't be equal to -3, so we use a round bracket. So for interval, we've got 2 round brackets. We've got -infinity to -3. And then for the graph, I'm going to have an open circle at -3. and my line's going to go to the left. So I'll start here on -3 and drag to the left. I want to make sure I drag that till that arrow shows up on there. Do that a little bit there. Okay, so here we've got question number 6. And so, so this is all about the vertical line test. Okay, so we can tell if something's a function or not if it passes the vertical line test. So if it's a function, if I imagine a vertical line going through these points, would that vertical line touch the graph more than once? And if the answer is no, then it's a function. So this one, the answer is no, the vertical line does not touch that graph more than once. Same thing on the second one here. A vertical line kind of passing through this, right, would not touch that more than once. On the third one here, we've got this circle, and so I can imagine a vertical line going right through the middle here, right? It would touch that in 2 places, so that is not a function. And then this one here, imagine a vertical line going through this, right? This right here, that would also touch that graph more than once. That is not a function. This one, vertical line going through a horizontal line, that's a function. And then this last one here, there's no place on here where a vertical line would touch that more than once, so that is a function. Okay, so 4 of those pass the vertical line test, and then these 2 do not pass that vertical line test, so they are not functions. All right, so let's see this again. Okay, looks like we did okay there. Number 7, so they give you a bunch of tables, and they ask you to tell which one is a function, which ones are functions. And so the way that we look at this, right, the definition of a function is that each domain, right, each x value only goes to one y value, right, y value. That's the range. Okay, so each domain, the x value, only goes to one y value. And so if I look down through here, I can just look at my x values, and you can see all those x values are unique. And so, so they all only go to, there's only one x value in each one of these, right? So they only goes to one y value. So that is a function. On the second one here, I'm looking down through here, I see a 3 and a 3. And this 3 goes to 2, so first 3 goes to 2. The second 3 goes to 10. So 3 in the domain goes to both 2 and 10 in the range. That's not a function. Here on the third one, I've got 2 goes to 3 and 2 goes to 6. Same situation. One value of the domain, 2, goes to multiple ranges, so that's not a function. And then on the last one, -5, 2, 5, 8, 15, all those values of x are unique, and so I don't have to worry about them going to different values of y. So this one is a function. Okay, number 8, we start looking at excluded values. Okay, so if I have this function, f of x, and it's 1 over 8x plus 4. Okay, so remember that the domain is all the potential values of x. And so in this one, where we have this function here that has an x in the denominator, if this in the denominator, if that denominator was ever equal to 0, then my function would be undefined. So I can say that the domain, for the domain, right, 8x plus 4 cannot be equal to 0. Right? So whatever x value would make this 0, x can't be that. So if I just solve this, I would have 8x, subtract 4 from both sides, I get -4. Divide both sides by 8, I get x cannot be -1/2. Okay, so x was -1/2, this function would evaluate to undefined, so that doesn't work. So -1/2. Number 9, they give us this graph here, and I'm just going to make a quick kind of copy of this graph here. And so it goes from 1, 2, 3, 1, 2, 3, 4, 5. So down here, and then over here it goes to 2, 0, and then up here 1, 2, 3, 4. So it goes through this point here. So it's going through here, and over here, and this is an open circle right there, right, on 2. Okay, so if I look at the domain is the x values. So if I look from the lowest to the biggest, right, the smallest to the biggest, and we want these in interval notation. So the smallest that x could be would be over here at -3. So this is -3, -5. This is 2, 0, and this is 0, 4. So if I look at the x values go from -3 all the way over here to 2. It can be equal to -3. We've got a solid dot there. It can't be equal to 2. So -3 to 2, square bracket, round bracket. From range, I'm looking from bottom to top. Now, a very common mistake people make is they just look at the ends and they say, well, this goes from -5 to 0. But that's not really where that graph goes. The graph goes from -5 all the way up to 4. And so there's the top of my graph right here. So my y values go from -5 up to 4. And since it passes through that point, it includes that value of 4. It's got a solid dot here, so it includes this value of -5. So my range goes from -5 to +4. Square brackets on both of those. So my domain is from -3 to 2, a round bracket. And that should be a square bracket. Yep, -3 to 2. There we go. Okay, and then the range here, I'll use the interval notation here, square brackets. It's going from -5 to 4. Number 9 here, they're asking, or sorry, question number 10, they're asking about this function here. So this is, they give us f of x is equal to the square root of x plus 1. And again, we're thinking about the domain, right? What are the possible values of x? Where is that function not going to be defined, right? And it just so happens that we can't have this, we can't take the square root of a negative number. So if anything in here, if any part of this becomes negative, then I know that I can't use that number. So what I'm really saying is that this underneath this radical sign, x plus 1, has to be greater than 0. Has to be greater than 0. And it could also be equal to 0. The square root of 0 is 0. Okay? So x plus 1 has to be greater than or equal to 0. And so if I solve that, that just tells me that x has to be greater than or equal to -1. All right. So when I talk about the domain here, right? The domain is going to go from -1, right, to positive infinity. -1 to positive infinity. All right, so I'll use my interval notation here. Go from -1 to positive infinity. Okay, and then before we submit this, I want to go ahead and look at the graph of this, because they do say here, you may find it helpful to graph the function and then look at the calculator. So we switch over to Desmos here, and I put in this function, y is equal to, and I need to get my square root here, square root of x plus 1, and I look at that graph, right? I can see that that graph starts here at -1, right? And that's a -1, right? -1. And it just goes on forever and ever, right? It keeps going to the right, and I can see it, it never ever ends there. So you can see that the x values go from -1 to positive infinity, right? So that's what we saw when we did it algebraically. Okay, so -1 to positive infinity. So go ahead and submit that. Okay, and we take a look at problem number 11. Number 11, similar sort of a thing. They give us a function here is equal to the square root of x plus 5, so we can kind of use that same reasoning. We know that x plus 5 has to be greater than 0, and it could be equal to 0 also. And so if I subtract 5 from both sides, I have x is going to be greater than or equal to -5, which means that -5 is my smallest value, and positive infinity is my biggest. So I'll use the intervals here. I got square to round, got -5, and positive infinity. Question 12. So they're just asking us to evaluate this function at different x values. So they want to know f of -2, f of -1, f of 0, f of 1, and f of 2. And they gave us the function here. The function is f of x is 3x squared minus 7x plus 3. So minus 7x plus 3. Now, I can go and plug -2 in and calculate all those. That's an easy thing to do. F of 0 is an easy thing to calculate because when x is 0, this term becomes 0, this term becomes 0, and so I'm just left with 3. So that's an easy one to figure out. But the rest of these will take a little bit of calculating. So what I'm going to do here is instead, is I'm going to switch back over to Desmos here. Get this out of the way here. Switch back over to Desmos, and I'm just going to go ahead and put this equation into Desmos. And so I've got, and I'm actually, take a shortcut here, I'm going to copy and paste. And so I just need to double check that I got it right. That should be a square. Okay, so I've got 3x squared minus 7x plus 3. Okay, and so to turn that into a table of values, I just need to go up here and go that, turn it into a table of values, and there I can see all of my values there. So I can also see the graph over here as well, and I can see what all those values represent, right? It'll even show me the points on there if I zoom out far enough. Okay, so it's pretty easy to go down through this list. So f of -2 is going to be 29. F of -1 is going to be 13. F of 1 is -1, and f of 2 is +1. All right, so now I can switch back to my problem and go ahead and just fill that table out. So this is going to be 29, 13, 3, -1, and +1. So question 13, they give us this graph here, and so they want us to look up, they don't actually tell us what the function is, but they want to know what f of 1 is. And so f of 1 means when x is equal to 1, what is the y value? And so for this, I'm just going to look that up on my graph here. So I'll make that graph a little bit bigger. I'll come over here to where x is 1, come up here, see where it hits the graph, and I can see that the y value there is 3. And so I can just fill that in. F of 1 is equal to 3. So f of 1 should be equal to 3 right there. Number 14, so they ask us to look up some values in this table. First of all, they want to know f of 5. So this means when x is 5, what is y? So I look over here where x is 5, that's right there. And when x is 5, the y value is 53. So that's going to be 53. The second one, they want to know where the y value is 7. So I'm going to look up here, the y values, right, f of x when it's 7, right? My x value is 2. So my x value here is going to be 2. So that's just looking at these values. Okay, so here they give us a graph, and they want to know where it's increasing. Okay, so where it's increasing. So where is it increasing? Well, it's increasing across here, right? It's increasing from this point right here at -1 all the way up here to, it looks like 2.5. Okay, so make that a little bit bigger. So from -1, right, it's increasing all the way up here, it looks like to 2.5. So those would be my x values. It's going from -1 to 2.5. And it goes through those points, so they're going to be closed brackets. And so this is from the interval, yeah, I'll use that. And so it's going to be -1 to 2.5. Okay, so to 2.5. Okay, and the decreasing intervals. Well, the decreasing intervals, on the left side, this graph keeps going. So this is going to be from -infinity, right, to -1. So this is going to be from -infinity to -1. Okay, so let's see. Oh, and yeah, so -infinity to -1. Now, I chose round brackets here, and I'm actually rethinking this answer here. At the point -1, it's not increasing or decreasing, right? That's a minimum. So I think this should be a round bracket right here. This should be a round bracket. And then this should be a square bracket. Oh, sorry, this should also be a round bracket. 2 round brackets. There we go. Okay? And then, so from -infinity to -1, it's going to be decreasing. And then over here, from 2.5 to +infinity, it's also going to be increasing. Now, the way that we list the two of those together is we say it's this interval, and this means the union is and from 2.5 to +infinity. And, oh, I forgot my comma right here. I was still trying to figure out why they said that was invalid, and I just forgot my comma. Okay, so from -1 to 2.5, it's increasing. From -infinity to -1, it's decreasing. And from 2.5 to +infinity, it's also decreasing. And at these points, -1 here and 2.5 here, it's neither increasing nor decreasing. These are the minimums and maximums, right? So those are the relative extreme. Okay. And I think if you put square brackets in on those, it might mark those wrong. So, okay, next question. Ah, that was the last question. Okay, so so we can see here, we can actually check this, right? If we put positive brackets on this, let's put a positive bracket there and there, positive bracket there, or a square bracket, sorry, square bracket there and there, okay? And then we submit that, it should mark that wrong, okay? And it does. So we want to make sure that those are round brackets on this, okay? Since I'd already submitted a correct answer, it didn't actually mark it wrong, but you can kind of see the result there. Okay, so that's all for that, that practice test. I hope this helps, and please let me know if you have any questions. Thanks for watching.